one final example of a geometric series. We have the series n equals 2 to infinity, 1/5 to the n plus 2/3 times 1/4 to the n. And similar to the previous example, we're going to break this up into two separate series, see whether or not both series converge. And if they both converge, then we can go ahead and find the sum. So starting out, this is going to be series n equals 2 to infinity, 1/5 to the n, plus series n equals 2 to infinity, 2/3 times 1/4 to the n. Right. Now, for both of these, it's actually pretty easy to find r and n. Let's find r first because we want to make sure that they both are convergent. So in this case, r1 is a fifth, okay, and clearly that's less than 1 if we take the absolute value, so that's good, right? And then over here, r sub 2 is a quarter, and the absolute value of that is less than 1 as well. So that's convergent. So no matter what, we know that this is a convergent series, okay? So because they both converge. And again, just like we explained in the previous video, if either of the two series or even both the series are divergent, then the entire series diverges. All right, so this is convergent. Okay, now A1, okay, is going to be found when n equals 2, right? So that's going to be 1/5 squared, which is 1/25. Okay, and then I'm going to call this a sub 2. That's going to be 2/3 times 1/4 squared, right? And so that's going to wind up being, I think, 1/24th, okay, because that'll be 2/3 times 1/16. All right, and then that just becomes an 8. So we get 1/24 for A2. All right, so keep these in mind. We might have to use some computer algebra system uh, if the numbers get too out of hand. All right, number R1 is a fifth and R2 is a fourth. All right, so let's find sum 1. So the sum of the first is going to be equal to a over 1 minus r. So that's 1/25 divided by 1 minus a fifth, which is the same as 1/25 divided by 4/5. All right. And I believe that's going to be 1/20th if we work that through, because that'll be 1/25 times 5/4. And so that should be 1/20th. All right. So that's the sum of the first series. Now, sum 2 is going to be equal to a, okay, which is going to be 1/24th divided by 1 minus a quarter, or that's going to be 1/24 divided by 3/4, right? And I do believe that's going to work out to be 1/18th. All right, so that's going to be 1/24 times 4/3. That's going to cancel out. It's becoming 6. And so we have 1/18th. All right, so what is the total sum? Okay, so sum 1 plus sum 2 is 1/20th plus 1/18th. All right, and I'm going to cheat. Okay, so sorry, I'm going to use Wolfram Alpha just because I don't feel like finding the common denominator between 20 and 18. So 1/20th plus 1/18. So 19 1/80s. Okay. Should have known it was going to be something with 180 in the denominator because it always is. So that's going to be 19/180. All right. So, and that's the sum of the entire series. Okay. So keep that in mind that you can still use Excel to check this. All right. So, hopefully that gives you several different examples of geometric series. Okay. In our last video, we're going to take a look at the idea of what a telescoping series is. Okay. And a telescoping series is quite different than a geometric series, but just like a geometric series, we are going to be able to find the sums of them. Okay, so that's important as well. So, but for now, we're done with geometric series. So go back, make sure you're okay with geometric before we move on to telescoping.